Question 6b. This question again requires us to use Euler's theorem and results from question 5, this time to determine 3 to the power of 2468 mod 2456. We saw in question 5b that 2456 is equal to 2 to the power of 3 multiplied by 307 as its prime factorization, and Euler's phi function applied to 2456 gives 1224. 3 is not included in the prime factorization, so 3 and 2456 are coprime. That means, by Euler's theorem, that 3 to the power of 1224 is congruent to 1 mod 2456. Now, as before, we need to try to get a number that's closer as the power of 3 to the 2468 that's given here. And it's obvious that if we square this number, that will multiply the power by 2, and 3 to the power of 2448 is congruent to 1 squared, which is 1 mod 2456. And now we are only the power 20 away from the power 2468 required. In other words, 3 to the power of 20, that is 2468, must be congruent to 3 to the power of 20. Multiplying both sides of the congruence by 3 to the power of 20, we get this. And that means that 3 to the power of 2468 is congruent. 3 to the power of 20 on your calculator will give 3486784 mod 2456. And when we divide this enormous number here by 2456, we can see that the answer we get is 1201 mod 2456. And that's the final answer. Just a comment on that. On your calculator, when you divide this enormous number, so this is 3 to the power of 20 divided by 2456, the answer is 1,419,700.48, and there's a decimal after that. And what we do is we take that number and we subtract away the 1,419,700, which gives us the decimal 0.489065 or so. And we then multiply by 2456, and that gives 1200.999 and so on, which is where this 1201 can be calculated quite easily.